Okay, so let's now talk about reactions with aromatic compounds. Like I said, aromatic compounds don't do similar reactions as they do with double bonds because these are stable molecules because of the resonance that we have in this circle here. All right, remember those electrons are going around and around and around. I kind of showed you how these arrows kind of show how it's going around. Okay, basically it's a substitution reaction. Uh, H is going to be substituted for one of the atoms that's attached to your X and Y. Both of them do not get put on. That's the difference. Okay. If you're going to halogenate, so dichlorine, you have to add iron chloride as a catalyst. Okay. Why would you want to do this? Well, DDT is a pesticide. All right. How do you think you're going to synthesize this? This is not naturally occurring, so you have to synthesize it somehow. You have to attach these chlorines on. So you have aromatic compounds. You just add chlorine with iron chloride and you can attach the chlorines. Okay, nitration. This is kind of a huge thing. Nitration. Nitro compounds are explosive. Have you guys heard of TNT? Of course you guys heard of TNT. Who hasn't heard of TNT? Do you want to know what this stands for? It stands for trinitrotoluene. Why do you think I made you know the word toluene? You know what toluene is. Toluene is a methyl group, and you've got 3 nitro groups. So if you take toluene and you triple nitrate it, you will have TNT. All right. So this uses nitric acid and sulfuric acid. You got to use the combination of the 2 acids, and you can put a nitro group on your aromatic ring. Okay. Nitration is also used for, let's not talk about explosive stuff, but it's also used for drugs. Okay, so the only way in order to make this NH2 is you have to first turn it into an NO2 and then you do another reaction on it that converts it into an NH2. Okay, but this is a sulfa drug. All right, this has been used as an antibacterial agent, or also para-aminobenzoic acid is actually antibacterial, but also as a sunscreen. All right. Sulphonation is the 3rd reaction of aromatic compounds. It uses SO3. Oh my goodness, seriously? Here we go. It uses SO3, all right, and sulfuric acid. And now I'm going to have that control thing there. All right, we'll just deal with it. There it goes. Oh, it's still there. I'm on the last slide, so it doesn't matter. All right, in sulfonation, benzene reacts with SO3 in the presence of H2SO4 to substitute for a hydrogen to give a sulfonic acid. All right, which you can, guys, I don't even know what's going on here. All right, well, anyways, that, let me put this on pause. All right, sorry about that, I got to figure it out. So here is an example of a detergent. All right, this is a detergent. To make detergents, you have to sulfonate. All right, notice that this is an acid. If you add sodium hydroxide to this, you can do an acid-base reaction. Your acid and your OH become water, and then you have a minus charge on one of the oxygens, and your sodium is the counterion, which is what that is right there. Okay, and that's basically a way that you can make soap, kind of the soaps that we have in shampoos, liquid soaps. You have to use a sulfonic acid group. All right, so that is it. Finally, we're done with this chapter. This is a long chapter. There's a lot of stuff in this chapter. Make sure you give yourself lots of time. Write down questions as you're reading, as you're going through this, and bring them to class so that I can answer any questions, go over any more stuff. There's a few things I'll probably still go over in class, but there's a lot of stuff in this chapter. All right, guys, make sure you do all your homework. All right, see you in class.